Let's look at a couple of examples for the view factor. Assume that we have two, I'm just gonna call it example one. Let's say we have two concentric spheres. So bigger sphere and there is a smaller sphere inside the bigger one. So let's call this one sphere 1 and this one sphere 2. And we're going to find out the view factor between two spheres that is happening. So based on what we have said here is the summation of view factor for each of these surfaces is going to be 1. These are in enclosure. So f11 plus f12 is going to be 0. Sorry, 1. The same thing, f21 plus f22 is going to be 1. Now, surface 1 doesn't see itself at all, so there is really no beam, radiation beam leaving this surface that can strike itself. So f11 is going to be 0. What does that mean? f12 is going to be 1. However, for the other one, for the other sphere, the bigger one, if let's say assume here there are some radiation leaving and then striking the surface number 1, but there are some of them that is leaving and then striking the same surface. So here the f22 is not going to be 0. Now I have another relationship that a1 f12 is equal to a2 f21. So from here I can find out f21, which is going to be a1 over a2 f12. Now this is a sphere, so it's going to be 4 pi r1 square. This is surface 4 pi r2 square times f12, which is 1. So here I can have f21 equal to 1 square divided by r2 square. So that's this one, and then I can use this relationship, the summation rule here, and I would find f22, which is 1 minus f21 equal 1 minus r1 square divided by r2 square. So this is for a simple geometry that we can find out the view factor. There are other examples that we would need to go through graphs or look at the already derived equations. Let's say we have two concentric cylinders. Cylinders of the radius of them are 5 and 10 centimeter. So this is the radius. And each of them 20 centimeter long. Now, let's calculate view factors here. Okay, so if I look at the cylinders, let's say I have this bigger cylinder, and there is another cylinder inside that, concentric. Here, the radius is 5, the bigger radius is 10. So this is 10. Now, if I label the surfaces, there is this surface A1 from the smaller cylinder towards the outer one, and this is the surface, let's say A2. There are two other surfaces here at the top and bottom of these concentric surfaces. So let's call this one A3 and this one A4. And let's find out the view factor for them. So R1 is 5 centimeter, R2 is 10 centimeter, L is 20 centimeter. Now, for this geometry, there are graphs that we can use, and I'm going to bring one of them here. So this is the graph for the two concentric surfaces with the radius of R1 and R2. R1 and R2, and the length of L, that from here we can find out, can read F21 from the bigger cylinder to the inner one, and this one gives us F22. That's for the radiation beams that are leaving this surface and striking the surface too. So to do that, what we need here, what we need to read is the ratio of R1 over R2, which is 5 divided by 10, or 0.5. And the other one is these curves are L over R2, which is 20 divided by 10. It's going to be 2. Now by having them, I can read most of them. So this is, let's say, if this is 0.5 all the way to the L over R of 2. So this is going to be the value of F21. So if we read the graph, F21 is approximately 0.43. For the other one, 0.5 and 2 is going to be here. About 3.3. So F22 is about 0.33. So these are the two view factor for the surface 2 that strike itself and between surface 2 and 1. But we have these two other surfaces that we need to find. But let's use other things that we have here. We know that F12 A1 is equal to F21 A2. So I can find F12 here, which is going to be A2 over A1 F21. Now the area here, area of the cylinder is going to be 2 pi r L, 2 pi r 2L, pi r1L, F21. Everything is going to cancel out except the radius ratio. So F12 would be the ratio of the radius 10 divided by 5 times F21, which is 0.43 that we read from the graph. So it's going to be 0.86. This is F12. Now the surfaces at the end of the cylinders, surface 3 and 4, they are symmetry. So whatever that we find for one surface is going to be applied for the other one. So there is a, let's say 3, and so we just need to evaluate for one of them. What does that mean? Is F13 is equal to F14, F23 is equal to F24. Now, if I write the summation of that summation rule for, let's say, surface 1, the summation rule tells us F11 plus F12 plus F13 plus F14 is going to be 1. Now, the inner cylinder, it doesn't see itself, so any radiation from this surface does not really strike itself, so F11 is going to be 0. This is 0. We have this value, and we know F13 and F14 is going to be the same. These two surfaces at the bottom and at the top, they are exactly symmetrical with respect to the A1. That's why we have this equality of the view factor. So from here, F13 is going to be equal to F14, which is going to be 1 minus F12 divided by 2. 1 minus 0.86 divided by 2, which is 0.07. So this is F13 and F14. The same thing, if I write the summation rule for surface 2, then we have F21 plus F22 plus F23, F24 is going to be 1. And we know these two are equal to each other. So F23 is going to F24 and is equal to 1 minus F21 minus f22 divided by 2. So it's going to be 1 minus 0.3 minus 0.33 divided by 2, which is 0.12. So that's the viewing factor between the surface of 2 and 3 and 4.